I'm Laith Wattar. I'm a senior mechanical engineer. So this is a Baja-based racing simulator. So this is the SR21 or 2021 year Baja frame. So I took this home last year. I repainted it, and I've been using this as a stationary sim. But I wanted to increase the immersion of the simulator. So over this past year, I applied for the ThinkBox Project Fund, and I received funding. For the motion system on the car. So I custom built 4 linear actuators and a motion system to simulate off-road driving. So these are 750 watt servos. There's a ball screw on the inside, and as that screw rotates, it pushes the shaft up and down, which causes the motion. And this was all fully custom built. The enclosure is 3D printed, and same with the motor spacer. The only thing that was machined was the tube on the inside, and then also the metal plate for the bearing to mount to. And then over here we have our electronics enclosure. So this has our 4 servo controllers, and then there's also a custom PCB in there that has 5 STM32s on it. And so it's set up in a 4 slave and 1 master array. So there's 4 STM32s for each, and then one of those is for each controller. And then there's 1 STM32 that connects to the PC, which receives the telemetry data. And using SimHub software, we're able to send all the telemetry data to the car and make it move. Obviously, something like this is quite expensive, and I wasn't able to really do something to this extent by myself. And I've been in ThinkBox for the past several years, and I love the building and the services available in the machine shop. And I saw online that they had the ThinkBox Student Project Fund available, so I applied for that and was successfully able to receive funding to build the entire simulator. I've been on the Baja team for about, at this point, 3.5, 4 years, and I really enjoy motorsport. While I'm not the driver for the actual racing car for the team, I build separate parts on the car, but I've always wanted to increase the immersion of a possible simulator, and we can use this frame in the simulator to then practice training our drivers to actually compete in races, and thus we might be able to do better as a team. And so, for instance, we could put this in a course fully virtually. Even if they crash, we're not going to damage the car, we're not going to wear down components, and we're just able to train the drivers without having as much costs on the car. For me, the hardest side was definitely the software side. So my entire background is mostly mechanical engineering, so building the actuators themselves and designing those wasn't very difficult. But the little black box here on the red side, enclosed in there was definitely many long nights of work. So one issue I had was the original software that I found on GitHub. In order to generate the pulses for the servos, it used manual read and writes, and so those are very slow. I was only able to achieve around 150 millimeters per second of linear actuator speed. So what I ended up doing is I taught myself some C++, and I was able to activate the hardware timers that are on each STM32. So what the hardware timer does is it basically allows me to generate a pulse at a much faster speed depending on the clock speed of the actual controller. So now I was able to increase the linear actuator speed from 150 millimeters per second all the way up to 500 millimeters per second, which is now essentially the max speed that the motors are able to apply, because they're capped out at about 2,500 RPM. And doing some simple conversions based on the ball screw length and the thread and the pitch, that's what we kind of expect for the top speed. So I'd love to learn, maybe some alumni have some insight on what I could change or what I could do to improve the simulator. Because this is obviously my first time doing something so significant, I guess. And while it does work, there's definitely some tweaks that I think I could do to make it perform better as well.